Good morning, students. Today's class topic is hypothesis testing or testing of hypothesis. Your hypothesis is like a goal in research. The goals are made to reach, or you set it as a last point where you want to end your game or whatever you want. So your hypothesis are the finishing lines in your research. So let's see what is hypothesis. Hypothesis is a predictive statement capable of being tested by scientific methods that relates an independent variable to some dependent variable. A hypothesis states what we are looking for, and it is a proposition which can be put to a test to determine its validity. So here hypothesis is useful in showing the relationship between your two variables, that is independent and dependent variables. So as I told, your hypotheses are like goals in research. You're setting a goal. So whenever we are setting a goal, we make a mind to reach that goal. Same way in hypothesis, when we are formulating the hypothesis, we try to prove our hypothesis whether it is right or wrong. That is whole meaning of hypothesis. You are predicting a statement. You are assuming that something can happen. That is your hypothesis. See the definition. Assumption or a statement that may or may not be true and is always tested on information obtained from a sample. So whenever you take a problem statement, you have certain samples, whether it is a small sample or large sample. So on the basis of those samples, you assume some statements that in the presence of those samples, these things can happen, whether it is in negative or positive, but you assume something that these all things can take place. That is on the whole is known as hypothesis. We can see the example. Why do leaves change color in winter? So this you can take that this is your like a problem statement, and you are going to have that you have a problem statement. Why do leaves change color in winter? And you want to have a research on this. So on this you have formulated a hypothesis. That is first you have seen here H. I think that leaves change color in the fall because they are not being exposed to as much sunlight. So your first hypothesis is that leaf can change color because they are not exposed to sunlight. Then second hypothesis is bacterial growth may be affected by the temperature. So your second is like for changing color, bacteria can be responsible. Then third one is chocolate may cause pimples. So this third one is absolutely not related to your problem statement. So is your hypothesis, which can be positive and which can also be negative and has no relation. That is, one hypothesis is correct and one hypothesis is wrong, and that is what you have to prove, that why your hypothesis is wrong and why your hypothesis is true. Then we'll see the purpose. Defining relationship between variables. That is, you have to show the relationship between your dependent and independent variables. Variable changing quantities in a study. So whenever you take samples, they might change quantities. So it is used for changing that quantities. In then independent variable, dependent variable, and control variables. Then we see the characteristics. Clear and precise. It should be in simple words. Capable of being tested. So you should formulate such hypothesis that you can test. Stated relationship between variables. Then limited in scope and must be specific. It should be specific. That is, it should be at one point. You should not create a story there. It should maximum minimizing 2 to 3 lines. Consistent with most known facts. So you are using the known facts around your samples. Then responsive to testing within a responsible time. So you are responsible for testing those hypotheses. One can't spend a lifetime collecting data to test it. So I told you should correct it in a limited time. You should not spend your whole time in proving your hypothesis. Explain what it claims to explain. It should have empirical reference. So it should be whatever you have formulated in your hypothesis, it should be stated. It should not it should not run around another matters, and it should be have some empirical evidences that is related to your time. State it as far as possible in most simple terms so that the same is easily understood by all concerned. But one must remember that simplicity of hypothesis has nothing to do with its significance. So, whenever you are stating a hypothesis, it should be in simple words that whatever people are around your research programs could understood your hypothesis. Then, why do we need to test a hypothesis? So, first is to make an assumption of a future event that is likely going to happen. As I have already told, that hypothesis is like a goal you are setting, that is you are assuming that it can happen. So it is telling that it is like assumption you are going to make that in future these things can happen. So for those things you need a hypothesis. Without a hypothesis, the researcher or whomsoever will be conducting studies will not be able to obtain hypothetical results. So without making hypothesis, you cannot proceed your research. That is, if you are not setting a goal, how can you proceed towards it? That is how you can start with your research to prove. So unless and until you are not making hypothesis, you cannot prove it by hypothetical results. By testing hypothesis, one may able to predict the information that is needed in the moment, but it may not be accurate result, just an estimate. So whatever you are trying to prove in your hypothesis, that is your assumption. So whatever result will come out of your hypothesis, that will not be accurate, but it will be an estimate, because your hypothesis is an assumption. Then we will see the concept, that is basic concept, or you can say types of hypothesis. So mainly there are two types, null hypothesis and alternate hypothesis. So your null hypothesis is always a false one, that is rejected one, and your alternate hypothesis is always the accepted one. So whatever hypothesis you are trying to make, in that null hypothesis will be having no changes, that is it will be rejected, and what is you are going to have another hypothesis, that is hypothesis 1, that is what you are going to prove about your problem statement. So it will always be accepted. So let's see what is null hypothesis. Null hypothesis is the hypothesis which we want to reject, denoted by H0, that is H0. So this H0 term means null hypothesis. Null hypothesis is the hypothesis which is tested for the possible rejection under the assumption that is true. It is denoted by H0. H0 may usually be considered the skeptic's hypothesis, nothing new or interesting happening. Then H0 is always stated as an equality claim involving parameters. So whenever you are formulating hypothesis, you will see there are no changes in your hypothesis, that is you are not going to show any result, so it will automatically be rejected. You can take an example. If you have taken 2 plant seeds and you are only watering on the one plant seed and not watering on the another plant seed, so it is obvious that you will not get a result, or you will see that there is no growth in the plant in which you are not watering. So that will be your null hypothesis, because it is not showing any result. Then we'll see next alternate hypothesis. Alternate hypothesis is the hypothesis which we want to prove and is denoted by H. No, H, you say here it is written HA, but mainly we write 1, 2, 3 and so on. So we'll see. Any hypothesis which is complementary to the null hypothesis is called an alternate hypothesis. It is usually denoted by H1. The acceptance or rejection of H is meaningful only if it is being tested against a rival hypothesis. HA is an inequally claim that contradicts H0. It may be one-sided. So mainly in alternate hypothesis, we formulate hypothesis in against of null hypothesis, and the main reason for formulating alternate hypothesis is to prove and which can be getting accepted. So that is your alternate hypothesis. that is, as I given the example of 2 seeds. So in that one seed was in which you was giving water, and in one seed you was not watering. So the seed in which you was not watering was null hypothesis, but whereas in which seed you was watering, that is obviously become a plant after 30, 40 or one day it will become a plant. So that is your alternative hypothesis that will give you a result and it will be possibly accepted. Then we'll see the errors. What are the errors in hypothesis? Mainly there are 2 types of errors in hypothesis, that is type 1 error and type 2 error. So you can see the image here. In type 1 error you can see a old man and the doctor is saying to the old man that he is pregnant. Then in type 2 error you will see a pregnant woman in which the doctor says to the pregnant woman that you are not pregnant. That means this is the error in your hypothesis. What is happening will be vice versa, that is what result you are getting, that will be against your hypothesis, that is you can say ulta or vice versa. So that will be showing the error. Type 1 and type 2 error. In that type 1 error, reality no relation. So in type 1 error there will be no relationship between your variables and decision rejects the null. So your null hypothesis will be rejected. Believe your research hypothesis have received supports when in fact you should have disconfirmed it. When you should have when you are formulating a hypothesis and your null hypothesis should be rejected, in those cases there will be no support of your null hypothesis. There will be no link of your null hypothesis with your variables. Then we'll see the next. Type 2 error. Reality relationships, that is shows the relationship between the variables. Decision accepts the null, that is in this case they are accepting the null. Believe your research hypothesis has not received support when in fact you should have rejected the null. So what vice versa is happening, that in null hypothesis, that is your type 1 error, the null hypothesis is having no relationship, but your null hypothesis should show the relationship, but it is showing in type 2 error the relationship. So it is vice versa, things are happening. In actual the null hypothesis should have relationship and the null hypothesis should be accepted, and in alternate hypothesis there are no relationship between your variables and it should be since there is no relationship, so it is very difficult to get accepted, but it is happening against of your natural hypothesis what is going to occur. So that's why they show the error. So here we'll see certain methods. What are the methods used to test the hypothesis? So these are t-test, z-test, f-test and x-square test or chi-square test. So these things you have studied already in statistical methods in differential and inferential statistics. So these things were under the classification of inferential statistics. So we'll see how it is helping here. T-test. A t-test statistical significance indicates whether or not the difference between two groups, average most likely reflects a real difference in the population from which the groups were sampled. So here the t-test shows the difference between two samples. So whenever there is a small sample size, so you are using t-test for the calculation of your value, that is t value, and for that case you are using this t-test. So see here, t-test for testing difference between mean t-test condition. Samples should be small, presumed to be drawn from the same population. Population variances are unknown but assumed to be equal. So whenever you are going to have t-test or you are using your t-test variable in hypothesis, so your sample size should be small, then only you can use this for your calculation. Then we'll see the next. You can see here the formula. T is equals to x bar minus u, then under that s by under root capital N. So this is the formula for the calculation of t test or t value. Then we will see the z-test. So here mainly we use z-test for the calculation of larger populations. So test conditions: populations are normal, sample must be large, presumed to have been drawn from the same population, population variances are known. So we are using here the z-test for the calculation of large population. You can see here the formula for the z-test. So we are always using z-test for the calculation of the large sample when you have taken your samples in large size. Then we can go for the f-test. F-test is a statistical test that is used to determine whether two populations have normal distributions, have the same variances or standard deviations. This is an important part of analysis of variance ANOVA. However, in case the population is non-normal, f-test may not be used, and alternate tests like Bartlett's test may be used. So it is used for showing the normal distribution between the two populations. You are not going to show the variances. So you are going to study those variances. You are not showing the differences between your variables, but you are going to study those differences. So for this case, we are using this f-test. Then there is chi-square test. We have already seen this in the second last classes. The tests we use to measure the differences between what is observed and what is expected. So mainly we are using the chi-square value in the expected value and is the result value. You can say like we can say our expectation is like, you can say for example, when there is a small child, they leave the small child. You can take your own example. You give an exam and you expect to get out of 10 you expect to get 8 marks, but you get 5 marks. So your 5 marks is what you have done and your 8 marks was your expectation. So same as in research, we are calculating the chi-square value from the result value and expected value. So what is the difference will come? That will be your chi-square test value. So in today's class, we have seen the hypothesis, that is a basic need for the research to proceed with the steps of research in order to prove the problem statement, and you have seen the errors, types and its need. That's all for the today's class. Thank you to all the students.